Welcome to Teach Me Animated Math. So what is a polynomial function and examples of it? In the second part of our introduction to polynomials, we'll discuss the technical description of polynomials. And after watching it, you'll be able to identify which functions are polynomials and which functions are not polynomials. Take note that you can watch the first part of our introduction to polynomials by clicking the I button. I also put the link in the description below. So what is a polynomial function? The short answer is that they are functions with expressions that match the definition of polynomials. And they can look like this. From part 1 of the introduction to polynomials, I mentioned that polynomials literally mean many terms. But what exactly makes it different from all other mathematical functions? A polynomial can be a mix of the following. It can have constants, like 5, -12, or 1/3. Also, variables, which are often represented by x, y, z, and etc. Polynomials can also have exponents in their variables, but only 0, 1, 2, and other whole numbers are allowed. It's just like 2 in x squared. There are also a few rules to identify what is not a polynomial. A polynomial cannot have division by a variable. If you think about it from the laws of exponents, division by a variable is equivalent to having a negative exponent. Also, polynomials mean many terms, but not infinite terms. This is important to remember, just in case your teacher throws you a trick question. So in short, polynomials can have constants, variables, and exponents, but they can't have division by a variable and infinite terms. To make the concept of polynomials easier to understand, you'll apply the definition to identify which expressions listed below are polynomials and which ones are not. Don't worry, because it's simple enough. Just imagine that you have a checklist. Let's first identify which ones are polynomials. This has a constant multiplied to a variable. Therefore, it is a polynomial. This has two terms which are a variable and a constant, which means that it is also a polynomial. This has two terms which are made from constants, variables, and whole number exponents. This is also a polynomial. This has constants, variables, and whole number exponents again. So yes, it is a polynomial. It may come as a surprise for you, but one term is also a polynomial. And yes, it can be just a constant. Next, let's explain why the remaining expressions are not polynomials. This has a negative exponent, which means that it violates the definition that variables in polynomials can only have whole number exponents. This is not a polynomial. This expression is divided by a variable, not a polynomial either. Square root of b is actually equal to b raised to 1/2, which means that the exponent is not a whole number, also not a polynomial. Similar to the last example, its exponent is also not a whole number, which means that it is also not a polynomial. This expression is divided by a variable. Yep, not a polynomial too. Your teachers can also refer to special names for polynomials with 1, 2, or 3 terms. Monomials are composed of only one term, and they might look like these. Binomials are composed of 2 terms, which look like these. Trinomials are composed of 3 terms, which look like these. You can easily remember these special names by thinking of cycles. Be sure to remember them because, who knows, they might show up in your exams. Next, let's talk about the degree of a polynomial. You will often hear the word degree when you use polynomials. Let's say that you have the following polynomials with only one variable. The degree of the polynomial is simply the largest exponent of that variable. This is a monomial with a variable y to the first power. This means that its degree is 1. This is a trinomial, and the term with the largest exponent is x squared. This means that the degree of this polynomial is 2. This is a binomial, and the term with the largest exponent is z cubed. Therefore, its polynomial degree is 3. This is a polynomial with 5 terms, and the 4th term has the largest exponent. This polynomial has a degree of 120. This polynomial is just a constant, which means that its degree is simply 0. Knowing the degree of polynomials will be more relevant when you start graphing these functions. But that is a more advanced topic that we will discuss in another video. There is an agreed way of writing polynomials. Try observing my sample polynomial functions in this video. I wrote most of them in what is called the standard form. It simply means that you write the terms in order of descending degree, the highest degree term first, and the constant last. Here is an example. The highest degree is 120, so write that term first, then 30, 15, and then the constant last. So, does the standard form affect the value of the polynomial function? Why do we need to write the polynomials in standard form? Nope, it won't affect the value of the function, and it's not actually required. It's just the writing convention that is most common in the world of math. Simply put, it's more convenient for people to write and read it this way. Okay? Alright, most likely, you are wondering right now why you had to go through the strict definitions of polynomials, right? The thing is, learning the definitions will allow you to easily work with polynomials. For example, if you add or subtract polynomials, then you'll get a polynomial. If you multiply polynomials, then you will also get a polynomial as a result. You can even divide polynomials, but that one might be a bit more complicated, and the result may or may not be a polynomial. And that's it! I hope you learned a lot in this second part of our introduction to polynomials. And with this, you are now ready to embark on a journey to polynomial mastery. In our next video, you will learn how to do polynomial addition and subtraction. It's a solve-along worksheet, so you'll have examples with step-by-step solutions that are very easy to understand. So be sure to subscribe to Teach Me Animated Math. And don't miss out. See you next time.